Okie doke, here we are again, this time two for the price of one. This is section 11.5, which is the tangent function, and 11.6, which is all these reciprocal, graphs of all these reciprocal functions. So once again, you should have a template, and a calculator would be a good thing, and maybe some sort of a highlighter or something to be able to highlight these things might be a good idea also. Now I'm not going to get really wild and crazy going into all various ways we could graph these. Your calculator will help you graph these, and for the most part, if you just know the main graphs, the basic graphs without doing lots of phase shifts and things like that, you'll be in good shape. One thing to know that the period for all of these is pi. So they all get one round done in pi radians. The other thing that's a good, I think, handy here is to also just kind of always keep in mind your unit circle, because part of this is understanding what's going on with domains and ranges. So we're going to start with y equals tan x, which is on the first graph. This graph also has tan negative x on it, which is just a reflection, which I'm not going to worry about that so much. So I guess I'll just use a marker here. So y equals tan x then, if you want to just use something to kind of highlight it, is what you see here. Now this particular graph, the way it was set up, is going from negative pi over 2, I think is what this is right here, and over on the other end here it's going to 2 pi. Now if you remember, tangent has interesting things going on. Tangent is sine over cosine, so I'll just quickly label this up. And so whenever we get to a place where we're going to take the y value and divide it by an x value of 0, tangent is what we call undefined. And so on this graph you will notice these dotted lines. And these dotted lines are occurring at those locations. And these, we've mentioned before, are called asymptotes. And so asymptotes are something you're going to get used to seeing. Now the asymptote itself doesn't really graph on your calculator. But these lines are where this function does not exist. So just be aware that you're going to see these things called asymptotes. These lines right here and here. So it shouldn't be too surprising then. This is the origin here on this graph, is at 0. So at 0, when we take sine over cosine, we get 0. And as we go around the unit circle, and we've talked about this not on this graph, what's happening basically is this graph has a range that's going for all reals, because it will go all the way up to positive infinity and all the way down to negative infinity. So just to review then, the domain for the tangent function then, I'm going to write this in a simple way, is basically x can never be pi over 2. So when we get up here to 90 degrees, it's got trouble. And then anytime we do another 180, it continues to have trouble. So it can't be pi over 2 plus n pi, where n is an integer. So any time I add another 180, if I do it once, twice, 3 times, etc., I'm going to run into trouble again. So that would be our domain. And as we've seen in the past, the range is all reals. And that's why when you look at this graph, when we lay it out on the x-axis, that this thing is going down, 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 and up, up, up. And every time we come to pi over 2, this would be negative pi over 2, this is pi over 2, 3 pi over 2, that's where we have trouble. Okay, let's just take a look at this on the calculator, because I want you to realize that there's no reason to freak out about these crazy looking graphs. Your calc would be happy to graph it for you. So I've already put this one in my calc, so if you hit your y equals and put tan x in and hit graph. Now if you do a zoom trig, it's not going to be this window. So what I've actually done is I've gone into my window and I have put in what I see on my paper. So this is negative pi over 2. I just typed that in right there. And then on my paper, this is going to 2 pi, so I typed that in. And every pi over 4, every fourth of a pi is what the scale marks are. So I just typed that in so that when I look at my graph, I'm seeing what I'm seeing on my paper. Now you'll notice on our graphing calculator, it doesn't produce the asymptotes. So you need to be aware that what's going on here is we have these asymptote situations where this graph never touches. It scrapes up close, but it never touches those locations. Okay, it is also possible that we could have phase shifts. We can have different movements going on here, although we're not going to worry so much about that in this class for these functions. But, I mean, someone could say, well, what does it look like if you were to graph tan of x minus pi over 4, for instance? And so, rather than having to kind of think this out yourself on paper, I would just suggest to become comfortable, with being able to go and graph it and look at it on your calculator and say, oh, x minus pi over 4. Oh, interesting. What's happened? It has shifted to the right pi over 4. Okay, moving right along. So now the reciprocal trig functions. So, and if you want to label these somehow, maybe, I mean, the first one's tangent, but I'm going to come down here and I'm going to label these other ones just sort of on the side. So, the next one is cosecant. So this is cosecant. And so if you want to take a marker or something, the function itself you can see here, and I think we've maybe looked at this before, so it's kind of a wild and crazy looking function. And also graphed on here is sine x, because if you remember, this is a reciprocal of sine. So if you look at what's going on here with sine as it's zipping on through here, at these places like 1 and negative 1, when you flip a 1 you get a 1, when you flip a negative 1 you get a negative 1. But on the sine curve, when you flip any of these fractions in here, say even something as simple as a half, so when you flip a half you get a 2. So all these fractions, when they get flipped, force this cosecant function to be either up above 1 or less than negative 1. So it has a different thing going on just because of the nature of the fact it's a reciprocal function. So as a review then, the domain then, remembering that cosecant is a reciprocal of sine, is going to be good to go except whenever sine is equal to 0. So the domain then is it can be anything, but x can never be n pi. So when you think about your unit circle, as you're going around your unit circle, anytime the y value is 0, that's when cosecant's going to be in trouble. So that occurs here and here. Okay, the range, and this is the one that's maybe a little trickier to write. I'm going to write it in what I think is the notation that's probably easiest way to write it. The range then is going to go from negative infinity with a parenthesis to negative 1 with a bracket because it's included, union 1, so it jumps this stretch here, union 1 up to infinity. Okay, so this, once again, no reason to freak out because you can always look at it on your calc if you can't remember. So I'm going to go ahead and hit my y equals here. I'm going to clear this tangent stuff out that I put in. And if I want to graph, remember I do not have a cosecant button. So if I want to take a look at cosecant, I need to type in 1 over the sine of x. So 1 over the sine of x. And I'm not sure what's on the paper. I'm just going to do a zoom trig for this one. You can dial in it to look like what's on your paper if you want to change the window. But this is a place where you can always go to remind yourself what cosecant looks like. And once again, remember this calculator is not going to graph these asymptotes at these locations where it's undefined. Okay, 2 down, 2 to go. Next up. The next one is the reciprocal of cosine. That is called secant. And if you want to do the same thing again, maybe grab something you can write with so you can sort of see it a little better than what you see on the paper. Secant has a similar look to cosecant. And it's all because it is the reciprocal of cosine, which is very similar to sine. And so all the same things I said before are going to be true here also, except that cosine has its trouble in a different location. Cosine's in trouble, or cosine is 0 here at 90, at 270, and continuing around and around, so that's when secant is going to not exist. So to review then, the domain of the secant function is going to be x can never be equal to pi over 2 plus n pi. And the range is the same as for cosecant. So the range goes from negative infinity to negative 1 union 1 to infinity. Okay, the last one is cotangent. And you can see tangent is graphed on here, and so cotangent you might want to just pick up once again whatever it is you're using to be able to highlight these things. So here's what cotangent looks like. So cotangent actually does look similar to tangent, but different. So what is cotangent? Remember that tangent sine over cosine. So cotangent is, let's go ahead and write cotangent over here. So cotangent then is cosine over sine, and so it's going to have asymptotes as we've seen, but it's going to occur when sine is equal to 0. So the domain of cotangent then is x can never be equal to n pi, and the range, which is similar to tangent, is all reals. And the reason for this domain range is similar to tangent we've talked about. I'm not going to get into it again today here. We can talk about it in class, but it basically has to do with what happens to fractions when one number gets really small and we do division. I think that's all I want to say about these for right now. I do really want to encourage you though to play around on your calculator with these, and questions having to do with these. I think your calc is probably the best place to go because they can get a little more confusing when we start moving them. So head on over to good old MathXL. There's some online homework to play around with these just a little bit more. See if you can start to get used to them.